Oh, for exam 1 review session, it's going to include intro, chem, cells, tissue, which is histology and integumentary. And the content, essentially, the lecture exam is going to include the following content that we talked about. The time frame is 1 minute per question, unless you have, unless you qualify for extended test taking. The lecture exam has 50 questions, 40 multiple choice, and 10 short answers at the end. The questions are placed in the order of, they're lumped together in the order of the chapter that they're in. So the first set of multiple choice questions you'll see will be on the intro, then the second one will be on chem, the third one will be on cells, and then tissues, and then integumentary. And at the end, you'll find 10 short answer questions, 2 per chapter, I believe. The lab exam has 30 questions, all identification, write in, no word, there's no word bank, and spelling counts. Okay. Any questions on the lecture or lab exam?
Actually, yeah, I do have a question, kind of like a point of clarification. So
Yeah.
I watched the video with the study tips on how to tackle the specific exam, and it said the woman who was narrating had talked about like study tips, and one of them was to like take a blank sheet of paper and like write mnemonics, like something blank, and write anything that's in your memory bank.
Mhm.
I just wanted some point of clarification to see if how outdated those tips are, and how that correlates with this exam.
Yeah, no, it's still very valid. So if there are mnemonics that you have come up with or ones that we shared in class, well, it's called a memory dump. So you have a blank piece of paper. You can have a blank, anybody can have a blank piece of paper on the exam. And what you would do is that you would share during the environmental scan, you would show the front and the back of it to show that there was nothing on it prior. And then you do what's called a memory dump. So you dump all the information that's more taxing onto that piece of paper.
Okay.
Yep. So that's a strategy that we suggest, for any kind of class, whether it's online or face to face. So you have a blank piece of paper, and then you do a memory dump, and then you put all the stuff that you remember, before you take the exam on that piece of paper, when the exam starts, not prior to that, of course. And then you can use that so that when you're taking the exam, the anxiety can cause you to forget. So, other questions? Okay. So the logistics is that you have to have respondents locked down like you have for the quizzes, and the webcam must be on. The exams will not be graded unless a complete thorough environmental scan is done. And that's really important, not for me, but for you, because if respondents flags you, I have to watch the environmental scan to make sure that there's nothing around you. So it's really important to do a thorough environmental scan. Make sure you show both your right and left sides, and then around the room. Some students in the past have just like done a really quick, up, down, side, and so I didn't really see anything. And then respondents had flagged their exam, so then I had to report it. So to my to my program director. So just make sure that that environmental scan is really meant to protect you, to make sure that that without a doubt there was nothing around you while you were taking the exam. No cell phones around you, of course. No, just making sure that without a doubt that you did it by yourself. During the exam, your full face must be on the screen the entire time. Respondents lockdown will notify me if you're not fully on the screen. In this situation, I will not be able to grade your exam, and you'll be given a 0 without the ability to retake the exam. Okay. So troubleshooting, try out the practice quiz first, because the practice quiz you can take anytime. Before taking the exam, make sure the internet is stable and the respondent is working, and test out the webcam functions using your practice exam first. If you do encounter difficulties, don't wait until the last minute to take the exam, because then, if you're taking it at 10 p.m., there's not much help we can obtain in terms of IT and such. Stay calm and close out, and then text me right away. And I believe you all have my cell phone number, so it's on the syllabus. and I will make sure that I'm around during that time to respond. Okay. If you encounter difficulties on the exam, and let's say something happens, it's best not to view all the questions. First, I'll have to check what the situation is, and if the situation allows for you to go back into the exam, I will open it only if you have not seen the test questions yet. If you've already gone through all the test questions and also something happens and you get kicked out, you've seen the questions, so I can't let you back in. So just a couple of things to think about as you're. So the best thing is to make sure you take it well before 10 p.m. on Sunday, or no, is it 10? No, 10 p.m. on Monday, and that way it gives us a lot of time to kind of triage and see whatever happens. Take one question at a time, all of them, and then go back. Hold on, let me admit a student in. Welcome. We're just talking about the exam information right now. So if you do encounter difficulties, just contact me right away. Recommendations, I sent out the 5-day study plan, the studying, assessing, and reviewing, testing and strategies, as well as there are suggestions as to whether you should study the oldest stuff first or the hardest material. That's up to you. Study complete chapters. Don't skip around because it's less confusing that way. Any questions on the exam before I move on? Okay. So in the introduction, it starts off with the scientific method. Make sure you know the terms and definition. Be able to define anatomy and physiology. Know the levels of hierarchy, starting from atoms to molecules to organelle, cells, tissue, organ system, and organisms. Some exam questions could be directly regurgitation, just memorization. Which of the following is considered to be the smallest living unit? What would you say?
Atoms.
What do you think? What's the smallest living unit?
They're atoms, aren't they?
Nope, atoms is the smallest unit, but is not considered to be living.
Living unit. Oh, be the cell, wouldn't it?
Cell would be correct.
Yeah.
So that's pure memorization. Other types of questions could be more of critical thinking. So for example, if I put, the question might be, which of the following I could ask which of the following is in the correct order of lowest to highest or highest to lowest. So for this example, let's go from which of the following is in the correct order from highest to lowest. And I'll say DNA, calcium, the heart. Okay, so you'd have to be able to apply and know that DNA is a type of what?
Is it a lipid?
Nope. DNA is its own biological molecule. So it's a molecule. Okay. So sorry, I didn't mean to give the answer away. So DNA is a type of molecule. What was the other example? The heart. The heart would be an example of the organ. And what was the other example I gave?
Calcium.
Calcium would be an example of atom. So you can see that it's not listed in the correct order. So you would not choose that option. Does that make sense? Questions? So smallest to largest. And if I said DNA, calcium, the heart, that would not be right. what if I said the heart, the DNA, to calcium? True or false?
False.
Okay. Calcium, DNA, and the heart. That would be the correct answer.
Mm-hmm.
If instead I switched it to largest to smallest, then this would become the correct answer. Okay, so make sure you read the questions carefully to see what it's asking for. Then a big thing that you'll find on the exam and actually throughout most chapters is homeostasis, the ability to maintain stable internal environments. Make sure you understand this definition and be able to apply how negative feedback and positive feedback is associated with that. So can someone volunteer to tell me what negative feedback is?
Is it where the body opposes a stimulus of an imbalance?
Yeah. So wherever there's a change, it opposes the change.
Mm-hmm.
And it does that to maintain what?
Homeostasis.
Perfect. Where positive feedback, is that a regular part of your body function? Is that a normal process?
Yes.
Yep, exactly. Both of you are right. So it is a normal process. However, it does deviate from homeostasis, which means then it amplifies. That's the key word. It amplifies the change. And because it amplifies the change, it can be dangerous, life-threatening. So examples of that would be things like childbirth, which is normal, but you know, it is life-threatening. Having a fever is normal, but it's the response towards infection. So fever is often a response towards infection, so that's why it is a normal body function. It shouldn't happen all the time, but it will if you have an infection. So it's a response to infection. Blood clotting is a response to trauma. Like if you have a cut or something happens along your blood vessels. Okay. So can you give me some examples of negative feedback?
Like when you get cold and you start shivering.
Yeah,
It's
body temperature
making-
regulation.
Yes.
What else?
The thermostat.
Perfect. So that's the body temperature example. What else? Blood sugar. So overall, negative feedback and homeostasis works like this. And we'll use the example of blood sugar. So your body has a set point for a lot of different values like temperature. Your set point is what?
$98.6.
Perfect. Or 37 degrees Celsius. Your set point for blood sugar is around 100, but now they're kind of changing what that is. But so for blood sugar, it's about 100. So let's say you haven't eaten, so your blood sugar is going to drop. And if your blood sugar drops below the set point, your body's going to release glucagon. And glucagon causes the sugars stored in your cells to be released so that the sugar is going to be released into your blood, and that causes your blood sugar to go up. Okay. And let's say you ate a really large meal, your blood sugar goes real high. Your body's going to respond by releasing insulin to cause it to go back down, and so on. So essentially, you fluctuate what we call a dynamic equilibrium around this set point. Okay, so that's homeostasis. through the process of negative feedback. It senses a change, it opposes it. Senses a change, opposes it. Senses a change, opposes it, and so on. Okay, so this is an example of homeostasis via negative feedback. Questions? Okay, and there were a lot of terms that you had to memorize for this chapter, so make sure, I recommend some type of flashcard or a Quizlet digital flashcard. And when you're using the digital, it will do it automatically for you. But if you're old school like I am, I use flashcards. What you would do is that you have a sheet, right, back and front. Okay, so on one side, you would write the term. On the other side, you would write the answer, the definition. And it should be nice and precise, okay? And what you would do is that you would flip through them, and whatever you get right, you put into one pile. Whatever you get wrong, you put into another pile, and then you focus on the one that you get wrong. Okay? And once you get all of those right again, you go back to the entire pack, and then you do it over again. So that way it's helping you to kind of focus on the ones that you got wrong more than the ones that you get right. Okay, so flashcards really aren't meant to be like your notebook, you know, because I see a lot of students just like put a lot of information in the flashcards. To use this as an assessment, this is what is recommended. Just short, brief, answer on one side, question on the other, and then you flip through them. Okay? Questions on intro before I move on? Okay. The next one is chemistry. I would set a lot more time to study this one because it's harder to understand because it's on the micro level. So something that you're less likely to be able to relate through. But on the positive side, it only makes up, you know, only a certain number of the questions are based on this chapter. I divvy the questions up based on how many chapters there are. All right. So starting out with chemistry, make sure you understand the terms, the difference between atom and ion. What's the difference between atoms and ions? Someone's got it.
Is it the charge?
Yes. So
Okay.
atoms are in the natural state of the element, so there's no charge to it. Where ions, they are charged. So they're either ions are classified as either cations or anions. So what is a cation then?
Cation is positive.
Yeah, and what I used to remember is that this plus sign in the T helps me to remember that that's cations are positive, which means anions are negatively charged elements or negatively charged atoms. Okay. So do you remember before when I wrote calcium? I wrote calcium as a Ca plus. So calcium is an example of a cation. Okay. Then you should know what a molecule is, what a solute is, and so on. So there's lots of definition terms. So again, flashcards. And in these flashcards, I'd even add examples. Okay. Then be able to understand molecules and their state. So molecules can be in the state of stable or neutral. What's the difference between stable and neutral?
Isn't stable bonded to another molecule?
Not necessarily.
Right. It depends on what's in its valence electrons, right?
That's right.
Or outermost.
That's exactly it. So give me further. You gave me the first part. Don't leave me hanging. What's the second part?
I'm trying to remember.
So you're absolutely right. It's about valence electrons. That's an A, by the way. Valence electrons. Oh, by the way, what are valence electrons?
The ones in the outermost energy level?
Perfect. And what about them?
Is it whenever they one molecule or that gives one away to another one? So
You're thinking about a specific type of chemical bond, specifically about ionic ones. So not quite yet. So just give me the definition of stable. That does have something to do with valence electrons.
Is it more stable if that outer layer is completely full versus just a few
You got it. That's it.
electrons? Okay.
That's exactly it. So it has the maximum number of electrons. And you can even say valence electrons in its outer shell. Or we use the term orbital. Okay, so you can use the term shell or orbital. They really refer to the same thing. So that's what stable means. What about neutral? Oops, what happened? There you go. What about neutral?
Isn't it something if there's the same number of protons and electrons and they cancel each other out?
Perfect. That's absolutely it. So the number of protons, which are positive charges, and electrons, which are negative charges, cancel each other out, which means they're neutral. Okay. Which ones are atoms? Atoms are always going to be what? You have 50-50. Now's the best time to make the mistakes because research shows that you'll remember it more on the test. Atoms are what? Stable or atoms are neutral?
neutral?
Yes, absolutely. So atoms are neutral. Now, which ones do they prefer to be? Do they prefer to be neutral or do they prefer to be stable?
Stable?
That's right. And that's why we have chemical bonds starting to form. Okay. So there are three, there's actually more, but there are three basic chemical bonds. There's ionic, covalent, and hydrogen. Which is the strongest?
Is it the chemical bond?
Yes, which chemical bond is the strongest?
Wouldn't it be covalent?
That's absolutely right. So covalent bonds are the strongest. And the reason for that is because in order to become stable, because that's what they prefer, right? To become stable, they share electrons. Okay, so they're sharing the electrons to become stable. So it's like two people. It rains and they're sharing an umbrella. They're going to share, they're going to stay together for a long time. Okay. Versus ionic and hydrogen. Ionic and hydrogen tend to be weaker bonds because ionic bonds transfer electrons to become stable. So here's this person, here's this person. So they transfer the electrons, so that causes one to become positive and one to become negative. And in ionic bonds, it's the opposites that are charged. But here's the thing. What if something else more attractive comes by? It's going to break that bond and go to the other one. Okay, so that's ionic bonds. There's a transfer of electrons, which makes one positive, one negative. But then it's easy to break because if something more attractive comes along, it will break that bond and then bond to the other substance. Does that make sense?
Yes.
Yes.
And then hydrogen bonds are very similar to ionic bonds. They're not positive or negatively charged ions, but they're more of polar and nonpolar. So they're based on like the overall molecular structure of it, but it involves the bonding to hydrogen ions. Okay. All right. So what's the pH scale? I wrote it on here, so I'm not going to ask you that. So it's a measurement of acidity, and the H in there stands for hydrogen. So it's a measurement of that hydrogen. The more hydrogen ions there are, the more acidic that solution is. The more OH there is, the more basic it is. So what does the scale go up to? What's the range of the scale?
0 to 14.
Perfect. And the middle being 7. So which side would indicate that there's more hydrogen ions and thus acidic?
0 to 7.
Beautiful. I love that. Okay. So 0 to not quite 7, but right before 7.
6.
Okay, that tells you, my finger keeps moving. That tells you that there's more hydrogen ions. The lower it gets, the higher the number of hydrogen ions, because this P right here, for those of you who are mathematicians, it's taking the logarithmic value of something. So in other words, the smaller the value, the higher the amount, the smaller the value, because it's taking the inverse of it. Okay, so that's why the lower the value, actually it represents the higher the amount. Okay, what would basic be?
8 through 14.
Yeah, above 7. Okay, that makes 7 be 7 what?
Neutral.
Perfect. Okay. So a sample test question might be, which of the following is basic? 1, 4, 7, 8. So
8.
which,
8.
yep, exactly. So which pH is basic? It would be 8. Okay. Then you have the organic compounds. That's probably what most students struggle on because it's just a lot. Whenever you have something that's a lot, I recommend making cognitive maps. Okay. Cognitive maps allow you to see what each one is and their relationship to each other. So there's a cognitive map. I believe there should be one in your study worksheets that I sent out through email. Does everyone get a chance to do those worksheets? Those are really helpful, at least what previous year students tell me. So the worksheets create the cognitive map for you, and you just need to fill it in. Okay, so let's just start with one. Okay, so this is what a cognitive map would look like. It shows you the basic what they are, what their function is, and their types and other characteristics. Okay, it's just a nice map to allow you to see each one individually and also how they relate to each other. So of the organic compounds, there's carbohydrates. What else would I fill down here?
Now, lipids, proteins, and nucleic acids.
Perfect. Okay. So I've expanded carbohydrates for you to give you kind of head start. So functions of carbohydrate, they can act as energy source such as glucose, energy storage such as glycogen, and they also can be found in cell structures like glycoproteins. Okay, glyco meaning sugar, protein meaning protein, or glycolipids that you find on the external surfaces of cells. Okay. Types, there's 3 main types. There's monosaccharides, which means one, mono meaning one. There's disaccharide, di meaning 2, polysaccharide meaning many. Those are the 3 main types. And within the monosaccharides, you have the glucose, the fructose, and the galactose. And then among the disaccharides, you have the sucrose, the lactose, and the maltose. Sucrose is formed by glucose and fructose because it's 2 molecules, which means it's a combination of these 2. Lactose is glucose plus galactose. Maltose is glucose plus glucose. So you can see that they all have glucose, and then they have the additional one to make them different. Okay, sucrose is table sugar. Lactose is milk. Maltose comes from wheat or whey. Okay, Then among the polysaccharides, when you have long chains of glucose, there are 3 types. There's starch, cellulose, and glycogen. You need to be able to tell me the identifying characteristics of each one. So an example of a test question that has been in the past is, which of the following polysaccharide is ingestible but not digestible? What would you say? Which of the following is ingestible but not digestible?
Cellulose?
Exactly. Or the question could be, which of the following is ingestible and digestible?
Is it starch?
Yes, ma'am. How about which of the following you do not consume but your body makes? There's only one left.
Glycogen.
Like,
Perfect. Okay. Does that make sense? Questions?
And it would say polysaccharide, like which of the following polysaccharides?
Yes.
Okay.
Yep. No? Okay. So you would do that for lipids, protein, and nucleic acid then. Okay, so I gave you one to kind of help you start out. I will be emailing this PowerPoint as well as the recording once we're done. I'm sorry. Questions on that before I move on? Okay. Then we have cells. Under cells, make sure you understand the structure and the function, the plasma membrane, and this is the one that gives students the most difficulty. So you'll notice that in my emails, I always include supplemental materials. Take a look at that. That will help. That usually focuses on things that are most difficult for students. Okay, so just a reminder to use your resources, which are the links in the emails that I sent out, as well as the links in the navigation material. Okay, so in the mechanisms of transport, there are 2 main ones, passive and active. What is the main difference between passive and active?
Does active use ATP and passive doesn't?
Perfect. One more difference.
Is it that passive uses like a gradient, like
Beautiful.
okay,
Yeah, I'm sorry, I cut you off. Go ahead.
concentration
Yes.
gradient? Okay, yes.
Perfect. So passive goes along a concentration gradient. In other words, it goes from high to low, where active tends to go against the concentration gradient. So it goes from low to high. Okay. So make sure you know the different forms. There's diffusion. So there's simple diffusion, oftentimes just written as diffusion. There's facilitated diffusion. There's osmosis and filtration. Be able to distinguish between those. And then under active, there's vesicle transport, whether it's endocytosis or exocytosis. And then there's active transport just by itself. So more of using the channels. Using the carriers, the protein carriers. Okay. Questions? Oh, here's a good question that you might see on the test. What's the difference between facilitate diffusion and active transport? Anyone want to try at it?
Is it that one uses ATP or it doesn't use energy?
Yeah, absolutely. That's one. Okay. How are they similar? How are they similar? So they're similar in that they both use a protein. Okay. But in facilitate diffusion, it's always a movement from high to low. But let's say these solutes right here are large and they can't make it through the normal areas right here. These openings. So let's say that these molecules are larger and they can't make it through. If it's still moving from high to low, facilitate diffusion says that it requires a channel to help it move through because the channel is bigger than these opens in the membrane. Okay, so it's still going from a high to low. It uses no ATP. The only difference is is that it requires a channel, a protein channel to go through. Okay, so the protein channels help it to go through, and it's going to go through because it goes from where it's high to where it's low. Where in active transport, okay, it's large, so again, it wouldn't go through the regular membrane areas. It needs a protein, so they both need a protein, but the protein in here is called a pump. Okay, and pumps require ATP because it's going to pump where it's low to where it's high. So similarities, they both use a protein, but one uses a protein channel and the other one uses a protein pump or a gate. Okay, and it requires ATP. And in active transport, it's going from low to high. Do you see the difference?
Yes.
Yes.
Okay. Make sure you know the organelles. This one everyone did really well in. The only thing I would recommend is to watch. I attached a video that clarifies more the difference between the endoplasmic reticulums. Okay, and just a reminder on the quiz. I'm sorry, on the lab you cannot use ER because that's an abbreviation. Okay, I'm just using it because it's short here. Okay, so remember on your lab exam you may not use abbreviations. Okay, so in the video that I sent, I differentiate between more of the function between the smooth ER and the rough ER. So make sure you take a chance, take time to watch that. Any questions before I move on to the next chapter? Then under tissues or histology, same thing. Make sure you know the structure and the function. There are four main types of tissues. There's epithelium, connective, muscular, and nervous. We will be focusing more on muscular when we get to the muscular system as well as the nervous system. So really, we talk about all four in this unit, but we focus on epithelium and connective. So these are the two that we really focus on. Okay. And again, connective and epithelium has a lot of content. So again, it's best to do a cognitive map to kind of see each one individually and how they relate to each other. So I highly recommend doing a cognitive map for each one. Okay. I include a link to the tissues chart that's on the navigation site. If you haven't seen it, make sure you kind of go look at it because it will make a chart for you, or it has a chart for you that you can just fill it in. Let me do something really quick. Hold on. I'm gonna stop sharing and find something really quick. Show you. None of them is there. Okay. Where would those be? All right. I had some chalkboard drawings of the class that I taught in person, and I wanted to share those with you, but I can't find them super easily. So what I'll do is I will include them in the email. It's just we constructed the cognitive map together as a class, so I wanted to have you take a look at that, but I can't find it right away. So to save your time, I will email it to you rather than have you wait for me to find it. Okay. All right. So any questions on this unit? It's a lot of memorization in terms of kind of how things fit together and what things are, but not huge amount of physiology, more of anatomy and overall function. Questions though?
Will any of the diagrams of the epithelium and connective be on the lab at all?
Absolutely.
Okay.
That's what all the lab would all be about, right? It's being able to identify what type of tissue things are. So it's exactly like your lab quizzes.
Oh, okay. No, I was referring to one of the other diagrams. It was somewhere, I think it was in the lecture, and I wasn't sure if that would be included in the labs.
Okay. So your lab content will only be based on the lab itself. So the lab PDF.
Okay,
Yeah.
I just wanted to make sure.
No, that's a perfectly great question. Yeah.
Okay.
Okay. All right. Then the last one is integumentary system. Make sure you understand the structures and functions. And then the integumentary system includes not only skin, but also nails and hair. So make sure you get those last two as well. We do focus mostly on skin, but we do make sure that you do talk about the nails and the hair. So on skin, using this one again, same thing. Definitely do those worksheets that I email out. Okay. So the worksheets that I email out will have you go through what are the layers and then what is in the layers in terms of what cells you could find. Okay. So the layers, you have the cutaneous membrane overall, which includes the epidermis and the dermis. And the subcutaneous layer is actually where you find the hypodermis. So skin makes up which one? The cutaneous, subcutaneous, both, or neither? What would you consider as skin?
Sorry, could you repeat the question?
Sure. What layers are included in skin?
It would be both the epidermis and the dermis, right? Because
That's right.
the dermis is on the top.
Okay. So a lot of students think that skin include both the cutaneous and subcutaneous, but technically it's just the cutaneous, the epidermis and the dermis. Okay. Then the epidermis, you need to know the layers from either deep to superficial or superficial to deep, which means you have to do what on the exam?
Label?
You don't have to label on the lecture exam. But you have to read the question though, right? You need to know whether I'm asking you from deep to superficial or from superficial to deep. You have to make sure you read the question carefully. So my recommendation for that is to read it out loud. Okay. So whenever I'm taking an exam online, I read it out loud because I'm in my own space. Where if you're taking an exam in class with others, you can't read out loud, but here you can. Read it out loud gives your brain time to process the question without having to read it multiple times. And sometimes you will need to read it multiple times. But if you're trying to be, efficient with your time, reading it out loud helps. Okay. So from deep to superficial, it would be stratum bacilli, stratum spinosum, granulosum, lucidium, and that's only found in thick skin. Okay. And corneum. Okay. So then you'd want to know which layer contains what cells. What are the characteristics of each layer? So a sample test question might be, which of the following layer contains all dead keratinocytes?
Is it the corneum?
That is correct. Okay. Or a test question might be, which of the following can you find melanocytes?
Stratum spinosum?
Which one?
The
think-
spinosum?
No?
Is it stratum bacilli?
Yes, that is. That's correct. Okay. So kind of make sure you having that cognitive map will help you see it visually, as well as be able to know what they are. Okay. And then moving on to the dermis, what tissue forms the dermis? What are the accessory organs? What are glands? What are hair follicles? What are pores, and so on? And also make sure you cover the last portion, which is membranes and glands. Okay. So you're probably thinking, oh, she's going to ask all in skin. No, that's not how we do the exam questions. So first of all the exam questions, we divide into the chapters. And then once we have the questions for each chapter, we divide up each of these kind of main buckets of questions. So you will have a question on the structure and function. You will have a question on skin. You have sets of questions on skin. You will have sets of questions on membranes and glands. So students often ask me, and that's a fair question, what's the exam on? And not to be, otherwise, but I would say on everything. It really is on everything, because we do take one from a question or a set of questions from each bucket. Okay. So just to kind of tell you how the questions are set up. Okay. All right. Questions on integumentary system before I move on? Okay. All right. So how to prepare for the lab? Go through the PDF one more time. And one thing I recommend on the PDF is actually, so if this is your PDF right here, and let's say these are what you have to identify, rather than writing down what they are, I would just put like A, B, C, D, and so on, and have a key right here. A is this, B is this, C is this, because then you can use your PDF as a quiz at all times. And when you're doing that, you have to get a new piece of paper and write your answers out. And by writing out your answers, you're also practicing spelling. Okay. So that's kind of how you will want to use your lab PDFs in the future. This is just a recommendation. Rather than writing down what they are directly, write it on, make a key, and then that way you can use it as a quiz each time. And that helps you with spelling because you have to write it out rather than just saying it out loud. Okay. What to study for the lecture, PowerPoints and videos. Okay. There are reading pages, but because the reading pages cover whatever the book covers in totality, you will have more than you need in those reading pages. So I recommend you using the PowerPoints and the videos as your numbers one source and the scripts, because that's where all the test questions will come from. The reading pages will have the materials that we want you to know in them, but they will also have more. So that's the reading pages has what you need and plus. So that's why I would not recommend you doing that first, but use that because it has more examples, more images, and it never hurts to learn more. But if you're already kind of stressed with the amount of material, focus on just the video and the PowerPoint and the scripts as your number one source. Okay. Studying, rewriting, writing your notes, rewriting your notes. Students in the 25 years that I've been teaching this class say that this is the number one thing that helps them. Just writing it out, rewriting their notes, and it's not copying either. When you're writing your notes, you want to edit it. So when you're writing your notes, it's not copying, because you can just put it into a copy machine and it'll copy it, right? So you want to edit it. You want to identify what you don't understand. You want to highlight key things so that it allows you to remember it faster, recall that information from your brain. Because here's the thing, right? So here's the content, here's the brain. You may be able to put it in, but you also have to practice pulling it out. So this is the process of studying. This is the process of assessing what you know from what you don't know. Okay. Review your quizzes. Let's see. So recalling the information, testing, you're doing a self-test, taking look at the test taking strategies, and I emailed you a video on that. Okay, so and that video that we made is specifically for this class. So it's test taking strategies for this class specifically. Okay. All right. So those are the main things I would recommend. And please, please, please make sure that your respondents and your camera is working. You do a very thorough, rather be careful than not, thorough environmental scan. Because here's the thing, I don't watch your videos at all unless respondents flags it. Okay. So I don't go in there at all until respondents tells me I need to go and check because it's detected something. And when I go in, the very first thing I do is I check the environmental scan. And if the environmental scan looks good, you're good to go, because that environmental scan protected you, showed me that there's nothing around you or in your vicinity. Okay. If you have any issues, any technical issues, text me right away. Don't email me, because I have to go into my email to be able to get it. So send me a text ASAP. And don't wait until the last minute, because I can't help when it's so close to the deadline.
Professor, I have a question about the memory dump.
Yes.
So it's a blank sheet of paper, and then did you want us to show the piece of paper after the exam starts or during the environmental scan? After the exam starts, correct?
I believe it is. So during the environmental scan, you can also show me back and front.
Okay.
Yep. And then I think it's during the environmental scan. Yeah, it's during the environmental scan that you want to show me your blank piece of paper. Yep.
Okay. And then is that allowed just on exams, or is that also allowed for the weekly quizzes?
Oh, anytime. Because it's a blank piece of paper. Yeah, anytime.
Okay, perfect.
Yep.
I also had a question about that.
Yeah.
So after I write down everything that I remember, we're allowed to look at it during the exam? Like, I thought the webcam flags your eyes for not looking.
It does, but remember that's why you do the environmental scan. So if you do the environmental scan and there was nothing there and you're just looking at your white piece of paper, your piece of paper that you showed me earlier that was blank initially, you're fine.
Okay, awesome. Thank you.
Yep. And if you know for sure that you're going to use some materials, it helps to have like a mirror in behind you so that it shows that you're using the same piece of paper, But if not, I usually can tell by the environmental scan anyways. Yeah. We're not doing this to assume that you are cheating, but if it flags you, it gives you protection. Think of it that way. Other questions? And you can ask any questions. If there's something you want me to cover in more detail, review with you, this is it. This is the time.